Ta-da.
Congrats. Let's
Okay.
go.
Right. Need to summarize how QtQuick draws at the moment. So QtQuick is responsible for drawing your windows on the screen, and then occasionally we draw effects on top. And the way it currently works is there's a simple path to draw all your windows, and then throughout this, effects have various hooks where you just randomly throw OpenGL calls in the middle of QtQuick trying to do its main business. And OpenGL code's quite long and old, so this is code to draw a circle. Not lots of circles, a circle. Don't expect you to read it, it's a lot of code. And I wrote a slide without knowing Martin was going to be here. The result isn't very good. It looks like it was written 10 years ago. Fair enough, it was. But the problem is, the QtQuick developers, the core developers, want to make the core even lower. They really need a fine-grained control of everything we're doing, changing which OpenGL call based on which drive you're using, what day of the week it is, and drawing onto different planes, and having absolute control of everything, knowing how long everything's going to take. And they want to have this really light scene graph with very simple rectangles, and long-term also have a path to Vulkan. And I say long-term, there's work in progress right now. And you can't have a path to Vulkan if you have loads of code throwing OpenGL calls at your screen. Now, as a not hardcore dev, that's not what I want. I want a very lightweight, simple API where I can draw in, load an image, load a texture, draw some text, which is really difficult in low-level OpenGL. And I definitely do not want to write another path for Vulkan. It would mean rewriting everything from scratch. So if we're going to do that, we need to look for a path forward that satisfies both of those sets of requirements, which are quite competing. So the solution is to have two solutions. Low-level QtQuick goes lower, and a high-level QtQuick where we need a high effects goes higher, making use of QtQuick. So your QtQuick code renders into a texture, into an off-screen buffer, which the low-level code just sees as a rectangle, doesn't care what it is. And if the high-level code wants to render a window or a whole desktop, it just sees a regular QtQuick item and doesn't care where that content comes from. And the main change was making all this happen really, really fast. With shared OpenGL context, we can make all of that happen. So it benefits. We saw that 20 lines of code to draw a rectangle. QtQuick, really easy. And also, the designers can come in along. People who don't know any C++ can come in along and add a color, which actually I've forgotten. But it's really readable code. It's really easy to edit, maintain, which is what we want. And we get features like anti-aliasing for free. So it looks like a nice circle, Martin. Sorry. But we also get interactivity really easy. So we had this overview effect in the past where it zoomed out and you saw all your windows. But doing a drag and drop of clicking a window and dragging it into another desktop, that was a lot of painful code. And sometimes we didn't have all of this code, where you can start searching and get KWin results. And that's really easy. All sorts of drag and drop and sliding and swiping. Not very difficult code now. And QtQuick 3D is amazing. And it's relatively easy to use. So we added a cube back, obviously, because everybody loves a cube. But I'll go for an example. We had that effect before where you click a mouse and you get a little circle. Why not a full 3D hand? And before I exported this to a PDF, this was a lot more exciting. So could you just pretend this is whizzing around with a vector animation on Euler rotation? Just imagine that. But it's not even very difficult code with QtQuick. You get a model, you run this magic command called Balsam, and then you've got your model, and you can just throw it in there. And you've even got all sorts of things for 3D. And obviously, we should throw more particles at things because particles are awesome, especially 3D particles. So we want to rewrite a lot of our effects, and that opens up to everybody. If you see any QtQuick effect code that is doing drawing, which is the part we want to really move over to QtQuick, grab it. It's quite a good task to get involved in Quin if you're interested. Or do cool stuff with 3D and particles. But get involved. That's the end. Yeah, it's lunchtime next. I'm not going to keep you.
Talk for 5 minutes more. You have the time. Any quick questions? Nice one. Okay, let's go for it.
For those on camera,
Let's
Martin
give
is
the
asking
people
a
time to
question.
prepare lunch.
Not really a question, but just a comment. So declarative QML effects is something I dreamed about something like 10 years ago, and I had concept of how to do it, but the technology was just not there. So I really love it.
Okay, we'll have another quick one, please.
Is this on?
Yep.
I just wanted to mention something you didn't mention in your slide, but for the current C++ effects, a lot of them also have a software path. So this is really nice. Instead of the separate OpenGL and software path, now it can all be through QtQuick.
That's
And
right.
that's quite a bit of complexity we could get rid of.
Yeah. So what we've currently got 2 paths. It was going to go up to 3. Now we've gone down to 1.